Okay, here we go. Like I say, it's short. Quiet, please. Okay. So this is the continuation of the 7-2 solving systems by substitution. But we're going to review, right, a system of equations. More than one equation, more than one variable. Like I said, that could be a quiz question, test question. The solution to a system is the set of points that satisfy both equations. Right? For two equations or two variables, it's the intersection point of the two graphs. Right? This is all repeat from yesterday. Maybe for Josh it's that. Right? Three possibilities. Right? What are the three possibilities for a system? Yeah, if it's one solution, what it means is that the lines have different slopes. Anytime you get two lines and they have different slopes, then they will intersect somewhere. I mean, what do we know about this? If two lines have the same slope? That's kind of the definition of parallel lines, right? What do you know about parallel lines? They have the same slope. So no solutions would be, they're parallel. Okay. And what does it look like if they have infinitely many solutions? It's actually one line right on top of the other, right? So how many points do they share? Infinitely many points, right? So here's one, and we'll change colors. Try to make it look like it's the same line. So I think I bring this up somewhere else later, but so this means M1 does not equal M2. They could have the same y-intercept, but they have to have different slopes. Right? What does it mean if they're parallel? That means that their slopes are equal. What does it tell you about their y-intercepts? They're not equal, right? If they were equal, if they had equal slopes and equal y-intercepts, it'd be the same line, right? So you have to say that the B's are not the same, right? And then this is the one that's got the slopes are the same and the y-intercepts are the same. They are the same line. Okay, the steps, which we just went over, but you should know them again. I could ask you that in a test. So now let's do a word problem that does this. Okay. Many businesses pay website hosting companies to store and maintain the computer files that make up their websites. Internet service providers also offer website hosting. The cost for website hosting offered by a website hosting company and an internet service provider are shown in the table below. Find the number of months after which the total cost for website hosting will be the same for both. Okay. So cost. So we're going to have two equations, right? For the ISP, we're going to have a cost equation. And for the website hosting company, I'll call that WHC, even though that's probably not something that gets abbreviated. There's a cost function. Okay. And we'll say that the month, M equals months. So what would be the equation for the cost on the ISP? There's a setup fee of $10 and then a monthly cost of $21.95. How would that look? Okay, so it'd be $21.95 times the number of months plus a setup fee, which doesn't change, of 10. Okay, and what would be the second one? For the website hosting company, it would be $22.45 times the number of months, and there's no setup fee, so that's it. Okay, so that's a system, right? Two variables, two equations. And this one kind of brings up something. I mean, this happens sometimes. But what's usually our first step in solving the system? You solve one of the equations for one of the variables, but actually both of these are already solved for C. So in fact, it's like saying if C equals this and C equals that, then this equals that. Okay, so it's basically, since C equals both of those, just set them equal to each other. There's an M missing. Okay, solve for M. What should I do to solve that one? No. Remember, what do you usually do? Remember, right, you deal with the variable terms first, and the smaller of the two is the one you want to move. So how do you get rid of a positive 21.95 M? You subtract it from both sides. Minus 21.95 M minus 21.95 times M. Go down. Okay, these cancel. I got 10 equals. What's 22.45 minus 21.95? 0.5 times M. Okay, last step. Divide by 0.5. So in how many months are their costs the same? So that should be 20 months. And so which one becomes cheaper after that? Yeah, the internet service provider has a monthly fee, which is less. So once you get to that point, you've paid off that initial fee, and you're making money on it. So if you plan to have it more than 20 months, you definitely want to go for that. Okay. So now the kind of problems that we haven't seen yet, which you are going to see, are like this. What do you do when you got decimals involved? I mean, in a way, does it matter? Not really, but what we want to show you about this is that actually there is kind of a step you could take to just get rid of the decimals. In each case here, how many places to the right of the decimal point do we have? 1, which means that column represents what? It's tenths. So what could I multiply by that would move the decimal place over 1? 10. So a lot of times when you get something like this, in order to get rid of the decimals, you could just deal with whole numbers or integers. What you would do is multiply by whatever it takes to move the decimal place over. It could be different for both equations, but in this case it looks like it's 10. Okay, what is this first equation going to look like if I multiply by 10? 10x minus 90 equals 5y, right? So make sure if you do that, you got to distribute once, twice, 3 times. Okay, how about the second one? What's that going to look like? 22x minus 31y equals, say it again, -2. So now it's still a system of equations, but there's no decimals involved. In fact, this one's going to be a little harder. Well, which one would you like to solve for which variable? The top one for which variable? Well, it's not solved because it's 5y.
Oh, no, the bottom one is.
How would you solve this one for y? And what would you get if you divided 10 by 5 and 90 by 5? Not fractions, right? Actually, 5 divides in, so there is kind of an obvious choice. So it's not as obvious as the ones we've done before. I would definitely, let's solve that one for y. Divide by 5. So this thing will give us y equals 2x, and what's 90 divided by 5? No.
Oh, wait, no.
Minus 18. So we're dividing by 5, 5, and 5. Okay, so that was our first step. Second step, plug it into the other equation, right? So in place of this y right there, we're going to put 2x minus 18. 22x minus 31 times 2x minus 18 equals negative 2. All right. So first step, distribute. Minus 31 times 2, 62x. Negative 31 times negative 18. Uh-oh. Lily? 558? Plus 558. Make sure the sign is positive. Okay, then what? Okay, subtract. 22x minus 62x is negative 40x plus 558. Okay, now we've got a two-step equation. Subtract 558. Let me scroll. Minus 558. Negative 40x. And Callie said that was negative 560. So how do you finish solving? Divide by negative 40. Negative 40. You have to flip the equal sign? Does that make sense? That's a trick. Okay, what's negative 560 over negative 40? Negative 560 divided by negative 40. 14. Positive. Okay? Yeah. Just a second. What's wrong? Try that. Okay, last slide. Right? So we're almost done. Is it working now? Okay. So also you could deal with fractions. If equations have fractions in it, you could take a step to get rid of the fraction. Right. So in the first equation there, what's the least common denominator between 2 and 4? What does it mean to say least common denominator? The smallest number that both denominators divide into evenly, right? So it's 4. So multiply the first equation by 4, what do you get? Right, so you're looking to multiply by a number that's big enough that it cancels all the denominators. Like, what is 4 times 1/2? 2x. What is 4 times 1/4? What is 4 times 1/4?
1.
So it's just plus y. And then what is 4 times 5? 20. Okay, what do I need to multiply the second equation by to get rid of the denominator there? What's the denominator? There's only 1. So you can multiply by 2, right? So if I multiply that by 2, what does that give me? 2x. What is 2 times negative 1/2? Negative y equals 2 times 1 is 2. Okay. So that's just taking, sometimes you call that, in math, you call that clearing fractions. Multiply by something that gets rid of all the fractions. Okay, now, we're still not done. This is a system of equations. First step, I got to solve one of these equations. Which one would you like to solve? I think the best one is probably the first one for y, right? Because it's positive 1y. Okay, quiet please. We're almost done. Okay, I solved the first one for y. Where do I substitute that? I put it in the place of y right there. So now I got 2x minus negative 2x plus 20 equals 2. So it's important to use parentheses because otherwise you might make a mistake with this negative sign. How do I deal with this negative? I got to distribute 2x plus 2x minus 20 equals 2, right? Combine like terms, 4x. Add 20. Divide by 4. Eleven halves. Okay. Next, we're not done yet. That's just one of them. How do I find y? I put it in the place in that the thing we solved for y in the first equation. That's the perfect place to go, right? So this would be y equals negative 2 times 11 halves plus 20. Y equals, what's negative 2 times 11 halves?
Negative 22 over 4.
It's negative 11. Now you won't go negative 22 over 4. Remember, you only multiply the numerator. It could be negative 22 over 2, but that's negative 11, right? The 2's cancel. Negative 11 plus 20. So y equals 9. So the solution is the point 11 over 2, comma, 9. So you may choose, especially with these calculators, to actually deal with the decimals and deal with the fractions and just let the calculator do the math for you. But these kinds of problems are out there. Usually we do something to get rid of the fractions and decimals. Okay? So that's the homework, and we are officially done.